Okay guys, we're starting gas laws this week, and your assignment is going to be a lab simulation. So I wanted to go through how that looks, and then also some of you might not be able to get to the link, so I'm going to show you or get some of the data for you. Okay, so if you go to the classroom, it's the gas law simulation lab. You'll click on the Google Doc, and here's what it is. I broke it down by points. We're going to look at relationships between pressure, volume, and temperature. We're going to create some graphs. I'll show you how to do that. And then we're going to make qualitative statements about the relationship between pressure, volume, and temperature. So we're going to see how those three things interact in a gas. I'm not going to go through all of this. A lot of this is going to be in the notes, so make sure you watch that video. One thing, though, that it's going to ask you is the relationship directly proportional or indirectly proportional? And so directly proportional means that when one gets bigger, the other gets bigger. And indirect means as one gets bigger, the other gets smaller. This should be an S. Okay, so here's the website. I'm going to cut and paste it in here. I'm going to do a split screen so that you can see both at once. The first part is just to, so when you click on this, you can download it. I'm not sure if you're able to do that on your Chromebooks or not. You can also just hit the play, but you need to have Java on your computer. So again, I'm not sure how that, okay, so it gives you, I'm going to scroll down. It gives you this little handle, so you can pump this up and down, and it allows different gas molecules to enter this little compartment. You can change the type of particle, so we have a light species and a heavy species. We can change the temperature. We can change how many particles we put in there by adding this. We can see what the temperature reading is, the pressure and the temperature, and we can also change the size or the volume of this box. We can choose to hold certain things constant, which I'm going to show you that in a little bit. So, so we're going to start here with number 1. We're going to reset. Okay, I'm going to do 1 pump. And then you're going to answer these questions. What's happening to the clump of particles? How does a single particle move? Is it straight, circular, random? Are they constant speed? What causes their speeds to change? Do they move in the same direction? If not, what causes their direction to change? Okay, so I'm going to reset again. So this is what that looks like. I'm going to put in, it says here to put in 100 heavy species and no, oh wait, sorry, I'm up here, 100 heavy species. Okay, so we did that. We're going to let our pressure stabilize. You're going to put the pressure there. Okay, so it looks like our pressure is about 11.5, I would say, with our heavy. Okay, so put for A 11.5. I'm going to reset and do, oops, I'm going to do 100 light. Okay, so it looks like they're moving quicker. But our pressure, again, for B is going to be about the same. I would say about 11.5. Okay, so you can answer C and D. Okay. Moving on to part 2, our partial pressures, we're going to put in 100 heavy, okay, and no light. We already did this, so remember it was about 11.5, so you could put your pressure right there. Okay. For B, we're going to put in 50 light and record our pressure. So it's about 6, I would say. 5.9 or 6. Okay, so put that for B. We're going to then put both of these in together. So the 100 heavy from A plus the 50 light. So we'll see what our pressure is. And it looks like our pressure is about 17.4-ish, we'll say 17.4. So for C, you can put in 17.4. And I want you guys to look at the pressures of A and B and how do they relate to C. Okay, so you'll do that for letter D. So the next part, we're going to use this constant parameters section. We're going to put our volume as constant. So I'm going to click on this little button. I'm going to reset actually. We'll put volume as constant. We're going to adjust the amount of gas molecules and temperature and see what happens to the pressure. Okay, so I'm just going to put in, as I put in 1 pump of molecules, it's about 5.5-ish. If I keep adding particles, it's going to go up. Okay, so pressure increases with the more particles that we have. Okay. For temperature, if I heat it up, okay, I can add heat. My pressure also increases with increased heat. Okay, so you want to write something for your defined pressure based on that information. It increases as we increase the heat. It increases with the more particles that we have when volume is constant. Okay. We're going to do the same thing, so reset. This time for B, we're going to define volume, but we're going to hold pressure and temperature constant. So I'm going to put in a little thing. We're going to put temperature as constant, and we're going to change the volume. Okay, so to do that, I get to move this little box. Okay, when I change the volume, if I make the volume larger, my pressure goes down. If I make my volume smaller, the pressure goes up. Okay, we're going to hold pressure and volume constant. Okay, so we're going to keep pressure constant and volume constant. So then we're going to see how changing the temperature affects, or how the temperature is affected. Okay, so if we increase the temperature, it's going to increase the volume, and decreasing is going to decrease. Okay, if I that's just changing conversions. If I change the volume, I'll let it come out. If I change the volume, let me reset this. We're going to keep temperature constant. No, we want to keep volume constant. When I change the temperature and volume is constant, my pressure increases and decreases. If I don't know if I can increase the pressure. Okay, so you guys are going to find a definition for pressure, volume, and temperature, and then predict how does the amount of gas present affect the three properties above. Okay, so the more particles we have, how does that affect our pressure, our volume, and our temperature? Okay, so that's kind of how you do this simulation. I'm going to do another video here that goes through part 3, 4, and 5, so that if you're not able to do this, actually we'll do part 3. I'll do another video for part 3. That'll show you what the data is and how to graph it. Then I'll show you the data for part 4 and the data for part 5. Okay, so that'll be in the next video here. So, alright, I will talk to you guys soon. Have a good day.